In this video, I'd like to continue to look at how we develop conversion factors, and then once we develop conversion factors, how we use those conversion factors to be able to convert from one unit to another. So this is the next worksheet that we will be getting, and on question number 9 it asks, what is the molar mass of ammonia? Now this 3 should be a subscript a little bit lower, NH with a lowercase or subscript 3. And anytime we're doing the molar mass, the first thing we write down is 1 mole of NH3 is equivalent to or equal to. Now it does not matter what order we put these in. Earlier we were putting the number of particles down first. And these particles, because N is a non-metal and H is a non-metal, N on the right side of the periodic table, on the right of this are all the non-metals, so it's a non-metal. H, even though it's on the left-hand side with all the metals, it's our one exception. It really belongs over on the other side with the non-metals. So it's two non-metals. So we're going to call these molecules. And it's molecules of NH3. And then that is also equivalent to, if we can do this in our head, great. There's one N, 14.0, and there's three H's, 1.0. So each H is easy to add up because there's three H's, it's going to count as 3. And then the one N worth 14, so the total is going to be 17.0 grams of NH3. Then we can only write this last piece if this is a gas and it's STP. If it's a gas, we're going to assume it's at STP, and it turns out that NH3 ammonia is a gas, so I'm going to write the last piece there. If this was a solid or a liquid, we would not be able to put the 22.4 liters. Now we have our 4 conversion factors, and now we're going to solve these problems. So for letter A, we're always going to write down what's given, 8.5 grams of NH3. They put the name down, but it's perfectly fine for us to write the formula. Now we're going to multiply by a conversion factor. Our conversion factor, remember, we've got 2 empty spaces here. We've got 4 things to choose from. Because it says grams right here, I'm going to pick the one that says grams. The number may match up and it may not. I just want to make sure I match up the units. So on the bottom, I'm going to put 17.0 grams of NH3. That way, the units will cross out. If the units don't cross out, I did something wrong. The numbers may cross out, they may not, but I'm matching the units. How do I know what goes on the top? I could put this one on the top, this one on the top, or this one on the top. I've already used one of them to go to the bottom. Now I have 3 more options for the top. The way I figure it out is I look to see what it's looking for. It's looking for moles, so I'm going to put the moles on the top. The way you know of the 4 that go to the bottom, you match up units. The way you figure out which one goes to the top, you look at the question being asked. So now we see if the numbers can be reduced, and they can. 8.5 happens to be half of 17, so I reduce that to 1 over 2. And now my final answer is 1 over 2, which is 0.5 moles of NH3. That's my answer. When I set up the next question, it gives me 8.5 grams of NH3. And we set up an empty fraction to do a conversion. My grams are still on the top that's given, so I'm going to put the 17.0 grams on the bottom. This time, though, they're asking for molecules. So I'm not going to put the mole on the top this time. I'm not going to put the liter on the top. I'm going to put the molecules. So it's 6.02 e to the 23rd molecules of NH3. Once again, the grams cross out. Once again, it's a 1:2 ratio. But this time, I've got 6.02 e to the 23rd divided by 2. Well, the 6.02, the way that scientific notation works, is that it turns into half, so 3.01, and the e to the 23 actually stays the same. So it becomes 3.01 e to the 23rd molecules of NH3. And then finally, they asked me for the volume. So I'm going to write down 8.5 grams of NH3. And I'm going to multiply by my conversion factor. Once again, since I'm given grams, I'm going to put the grams on the bottom, 17.0 grams of NH3. And now they're asking me for volume. Liters is volume. So I'm going to put the 22.4 liters of NH3 on the top. The grams of NH3 will cross out. The 8.5 is exactly half of 17. And so now I get 22.4 multiplied by 1, but I can ignore that, and divided by 2. So that ends up being 11.2 liters of NH3. I hope this helps developing our 4 conversion factors. As long as it's a gas, we can put that 4th in. If it's not, we can only develop 3 conversion factors. And then how to write down what's given each time, and then fill in those 2 empty spots with one of these 4, one going to the bottom and one going to the top. The bottom one, we always match up the units with what is given. The top one, we're looking for what is given, or what we're looking for, we find and put those units on the top.